So in the alternative clustering, we are going to learn the clustering, but there are some additional methods. If you look at the previous chapters about clustering, so you learn about the basic concepts, and then you learn about the partitioning methods, and you learn about the hierarchical methods. So in this section, we are going to learn the density-based methods, and then grid-based methods, and then how to evaluate the clusterings. We have another method, we call it the density base. So density. We are going to look at the groups. If the clusters is dense, okay, we call it dense, or in the local data, there are so many objects gathering. So we call it, this is the local clusters. And we have the criterion of the local clusters. One example for the local cluster criterion is the density connected points. So in this density connected points, yeah, we will look at the details. The major features, okay. We are going to discover clusters of arbitrary shape. Arbitrary. So yeah, any kind of shape. It can be, yeah. If you learn in K-means, it has only like convex shape. But in the density, you can have any shape. For example, you have this shape. You can have only small circle here, or you can have like something like a donut, like this one. So yeah, there are many kind of shape that we can extract with the density base. And we can handle the noise. The other features for this density base is one scan. So just scanning once, and then we can extract the clusters. And we need the density parameters as the termination condition. So there are some studies about the density-based clustering. This is the original one, dbScan. And then there are some other methods like optics, then Q-click, and so on. So we are going to learn about the dbScan. In order to do the density base, we need two parameters. The first parameter is EPS. So EPS, or sometimes people say as the epicentrum. Yeah, just let's use EPS. It is the maximum radius of the neighborhood. So if you have a kind of circle like this one, then the radius is from the middle of this circle to the edge of the circle. We have the maximum radius. Minimum PTS, or we call it minimum points. Minimum points. We call it min PTS, is the minimum number of points in an EPS neighborhood. EPS neighborhood. What does it mean? If the EPS is 1 centimeter, then we want to know any data that is inside the 1 centimeter. So we call this is the EPS neighborhood. in the formula, we have the NEPS like this one. So we have the NEPSP. It means the number, okay, it is the number of the EPSP. P is a particular point. So we want to know any other point which is inside of the EPS. So we have the Q belongs to D such as. So this is the condition. Okay. We have the condition. What is the condition? The condition is the distance between P and Q is less than or equal than EPS. So if I have like this circle, okay, so I know that this is the point P. Okay. And I have the EPS is 1 centimeter. Then if the distance with this point, let's say this is Q, if the distance is less than 1 centimeter, then we include this Q into the N. But if there is any point here, Q, if it is outside from the radius, then we will not include this one. Okay. We have the concept later, the directly density reachable. It means a point P is directly density reachable from a point Q. So I have P and then I have Q. So it is two different points. It is a directly density reachable. With regard to the EPS and minimum PTS, so the EPS is the maximum radius and the PTS is the minimum number of points, such as if P belongs to N. So it means if I know that the radius of Q is this one, okay, then P belongs to N. But if we have the EPS is this one, it means it is not directly visible. It is different. Okay. So if it is inside the EPS, so it is inside the EPS, then it is directly visible. The other condition is the core point condition. We call the core point condition means if this have the core point where the number of n is one, the number of data that belongs to this EPS is higher than the minimum PTS. Okay, for example, I have the EPS is 1 centimeter. And then the minimum points or the minimum data that is inside 1 centimeter should be 5. Okay. So if you look at the Q, let's say this is the Q. Okay. So this is the Q. And I will make the radius 1 centimeter. So this is the radius 1 centimeter. And inside this 1 centimeter, I need to have at least 5 points. So do I have 5 points here? Yeah, we have 1, 2, 3, 4, 5, 6, 7. Okay, 8. Okay, there are 8 points. So it means, yeah, it satisfied with the core point condition. Now, I would like to know the P. Okay, so this is the P. With the radius 1 centimeter, I know that this, and this, and this, it belongs to the N cube. Okay, so it means there are 4. 1, 2, 3, 4. But is it a core point? The core point condition should have the number of EPS should be greater than equal to the minimum PDS. Because the minimum is 5, but I have surrounding P is 1, 2, 3, 4. Okay, only 4. So it is not in the core point condition. Okay. After we have the directly density reachable, okay, so the previous one, we have the concept about directly density reachable. Now we will learn about the density reachable. Density reachable means a point P is density reachable from a point Q with regard to EPS. Okay, so the WRT means with regard to. The point P is density reachable from a point Q with regard to the EPS. So let's say the EPS I mentioned before, it was 1 centimeter, and the minimum PTS, with regard to EPS and the minimum PTS, if there is a chain, chain is a kind of consecutive connection. Okay. So if there is a chain of points P1, P2, P3 until Pn, such that the P1 is the Q and the Pn is P. Okay. So P1 is the Q and the Pn is P. So it means I can have a connection, or I have a chain to connect from this Q to this P. Then we call this is the density reachable. So we know that the Q and P is 1. It is not directly density reachable, but the Q until P is density reachable because we have a chain. We have a chain. We have a chain. There's another concept, we call it density connected. The density connected means a point P in the density connected to a point Q with regard to the EPS and min PTS. If there is a point O such that both P and Q are density reachable from O with regard to EPS and minimum PTS. So we call that this one. I have the point O. The point O, if you look at the distance from O to P and the O to Q. Okay. So we have this one, it is a group, and this group is density connected because there is a point O here, it is connected to P, and this is connected until Q, So this is this is reachable to Q, this is reachable to P. Then all of them are density connected. The word dB scan. Okay. The word dB scan, it is from the density-based spatial clustering of application with noise. Okay. So that's why they call it dB scan. It relies on a density-based notion of cluster. So it depends on the density base. That's why we have the density reachable and we have the density connected. So a cluster is defined as a maximal set of density connected points. So you know the density connected point means this one, density connected points. What we want is to discover clusters of arbitrary shape. Okay, so this is any shape in the spatial database with noise. So there are three kind of point that we will learn today. The first is core point. The second is border point, and the other is outlier. The core point, it is a point if there are at least minimum points, number of points in its neighborhood area with the radius EPS. Okay, so this is the same with this definition. The core point condition is this one. Okay. The number of points in the neighborhoods are greater than or equal to the required minimum points. We call this is the core point. The other point is the border point. The border point, a point is a border point if it is reachable from a core point and there are less than minimum points, number of points within its surrounding area. And the last one is outlier. A point is an outlier if it is not a core point and not reachable from any core points. Okay. Now let's see this example. Let's suppose I have the EPS 1 centimeter and I have the minimum PDS is 5. We call this point is a core point. Why? So this circle indicates the radius. The radius is 1 centimeter, and inside this radius we can find 1, 2, 3, 4, 5. Okay, so there are 5 points in the radius. So I can say that this is the core point. What about border point? In the border point, if this is a border point. In this case, when we have this radius, we have only 1, 2 point that is in the radius. So we call this is the border point because the border point, it has less than the minimum points, number of points in the surrounding area with the EPS 1 centimeter. However, this one still can be reachable. What does it mean? This is the core point. Okay, this is the core point, and it is still reachable to this border point. That's why we can say this is the border point, even though no points, no 5 points inside this radius. This one is outlier because it does not belong to core point and it is not reachable from any core points. So if you have like this one, for example, let's say here, this is also not, okay, let's say this one is the core point, so it is not reachable. Okay, we don't have any points in between, so we call this is not reachable. So the algorithm of this DB-scan, first select the point and then retrieve all points density reachable from P with regard to the EPS and the minimum PTS. So if P is core point, then a cluster is formed. If P is a border point, then no points are density reachable from P. DB-scan visit the next point of the database and continue the process until all of the points have been processed. Okay, let's see with one example. Suppose there are 13 points. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, we set the EPS is 0.6 and the minimum points is 4. Okay, determine the cluster results and the outliers. So at the end, we need to have like this cluster, and we need to determine where is the core point, where is the possible border point, and where is the outlier. Okay, so we finally we will get this result. How can we get this result? First, we need to calculate the distance. You still remember how we calculate distance? Okay, for example, this is the distance from 1, 2. Okay, in the matrix distance, let's say this is 1, 2, 3, 4, 5, and so on. Okay, it means we have the matrix. This is 1, 2, 3, and so on until 13. And we have also the y, 3 until 13. So we can have the distance from 1 to 2, 1 to 3, 1 to 4, 1 to, and so on until 1 to 13. Okay. Now let's just look the distance from 1, 2. So let's look the distance from 1, 2 to any point. The distance from 1, 2 to 1, 2 is 0. Okay. And the distance from 1, 2 to 3, 4. What is this distance? I think we use this Euclidean distance. Okay. So if it is an Euclidean distance, then it is 1 minus 3 power of 2 plus 2 minus 4 power of 2. And yeah, we need to do the square root. So the square root of 2 power of 2 plus 2 power of 2. It means 4 plus 4, it is the square root of 8. The square root of 8 is maybe 2.8 something. Okay. So it is 2.8 something. It is the distance between the point 3, 4 and 1,2. And so on. We can get the distance from 2,5, 4 with 1,2, 1, 5, 2, 5 with 1,2, and so on. Okay. Now, based on the requirement, what is the EPS? It is 0.6. So let's see. This is 0 because it is its own point, so we do not consider this one. What about the distance here? It is higher than 0.6. What about this distance? This is higher than 0.6. This is higher than 0.6. This is higher than 0.6. Okay. This one is good because it is less than 0.6. This one is no. This one is no. Okay. This one is less than 0.6. This one is no. And this one is no. Then the neighborhood points. What is neighborhood points? This is the point that is inside or less than the EPS. We have 1.2, 2.9. So we put this point into the neighborhood point of 1,2, and the other is we input the 1,2.5 as the neighborhood point of 1.2. And then what next? We will go to the next point, which is 3,4. We will do the distance from 3,4 to 1,2, the distance from 3,4 to 2.5,4. We will do the distance from 2.5,4 to 3,4 to 1.5 to 2.5, and so on. And after that, we will calculate again and check with the EPS 0.6. And we get this is the neighborhood point. So we will do scanning for all points. And this is the neighborhood points. Now, we have another condition, the minimum points. What is the minimum points? It means how many points in the neighborhood points. In this case, there are 2. In this case, there are 2. This 3, this 2, this only 1. How about this? We have 1, 2, 3, 4. Then we can say that this is one cluster. This one has 2. So this one 1, 2, 3, 4. Okay. We call this is the cluster. This is 1, 2. Okay, we have only 2. And we have 1, 2, 3, 4. Okay, so this is another cluster. Now, if you look at the details of this point, okay, if you look at those points, those 2 clusters are the same. Okay, we have 1,2, 1,2, 1.5, 2.5, 1.5, 2.5, and then 1, comma 2.5. Yeah, this is 1 comma 2.5. 1 comma 3, this is 1 comma 3. 1 comma 1.2 comma 2.5, this is also the same. Then those two are cluster 2 because the details of the neighborhood points are the same. So at the end, we can analyze. Okay. We know that if the number of points in the neighborhoods are satisfied, because we have the number of points in the neighborhood is 4, so this is the core point. This is another core point, and this is another core point. Okay. And then let's look at the other possible point, whether it is border point or it is outlier. Okay. Now let's look at this one. In this point, we have the yellow color. What is yellow? The yellow color is the core point. Okay, because it is reachable from the core point. And we call this is the border point. What about the second one? Okay, this is in the red color. What is the red color? Okay, the red color is the core point. So this is also border point, because the definition of border point, it should be reachable from the core point. The point number 3 is also a border point because it contains one core point. This one, it contains 1.2, 2.5. So it is also the border point. This also a border point because it contains 1 point. This also a border point because it contains the core point. Okay. What about this? Nothing in the neighborhood point. So we call this is outliers. This one is also outliers. And this one also outliers. Okay. So we can have the conclusion that the cluster 1 is the point in this section. It means 3, 4, 2.5, 4, 3, 5, 2.8, 4.5, and 2.5, 4.5. For the cluster 2, you can see this one, and the outliers are those 3 points. So you can look at the figures. Okay, so this is the core point, and this is another core point, and this is outlier, and this is outliers. So the DB scan, it is mentioned that the parameters is very sensitive. So we have the picture, the figure A and figure B. In the figure A, the minimum point is 4, but the EPS is 0.5. In this figure, the minimum point is 4, but the EPS is 0.4. So you can see the result. The result of the clusters here is different with the result of the cluster here. So you can see there are so many colors inside here. It means there are many groups, there are many clusters. But if you look at this one, it seems they create only one, almost one, because you can see still some like green or purple inside. But this one is better than this one to see about the clusters. However, when you change the EPS very small, then it will affect to the result. Now, you can see also from this figure, A, B, and C. So this is a DB scan result with the minimum point is 4 and the EPS is 5.0 for this one. And this is 3.5 and this is 3.0. Okay. So there's another way or another method to use this kind of density base. So in the method of Clarence, it is a method using some kind of condition, and we want to check if we have this data, and this data. So how the DB scan can work to find the arbitrary shape, to find the any shape from the clusters. So this is the result from one algorithm they mentioned as Clarence. Yeah, we can create the group. We can create the group here. We can create the group, but the group is still separated. Meanwhile, we know that it might be in the same group. If you look at the result from the DB scan, we can see that, okay, this is in one group. This is in one group. This is one group. This is also one group. So the group is based on the density. Okay, so that's why we call it the density base cluster. If you look at the second picture, using the Clarence, it is separated. The blue color is here, the green color is here, the red color is here, and the brown color is here. However, with the DB scan, it is in one cluster. It is in one cluster. It is in one cluster, and it is in one cluster. Okay. And there is tree with the Clarence. Yeah, you can see this one is one cluster, this one is one cluster, but this one is separated. Meanwhile, in the DB scan, you can see that this is one cluster and this is another cluster. Okay. Then which one is better? Of course, it depends on your data. If we want to find this kind of shape on your data, then the DB scan is better. Okay. Okay. Let's have a break. Okay? Let's have 10 minutes break. After the break, I will continue.